Okay, a permutation is an arrangement of items in a particular order. So if I were to take this class and I were to line you up in order from shortest to tallest, that is a permutation. Order matters, okay? If I were to say, I am going to rank you first, second, and third, order would matter. I'm only taking 3 of you at a time, but order would matter because I could take those same 3 people. So if I were to take this row here and I would say Mikey is first, Haley is second, and Kelsey is third, I could take those same group of people and do a different first, second, and third placement, right? And it would be a completely different first, second, and third placement. However, if I said, Miss Amy needs 3 of you to help her with something, if I said Mikey, Haley, and Kelsey go help her, it doesn't matter if I say Mikey, Haley, and Kelsey, or Kelsey, Haley, and Mikey. Order does not matter who's helping her, okay? So permutation order matters. It is a specific order. And so we start getting into what's called factorial. Factorial is this little exclamation point here. That is the notation for factorial. And what it basically means is start with the number that it wants you to do factorial of and multiply by every number below it. So for example, if I said 5 factorial, then that would mean 5 times 4 times 3 times 2 times 1. Okay? Now this is used in what's called a counting method. And so it happens when you're doing arrangements. If you look at example 1 here, in how many different orders can 10 dogs line up to be groomed? Well, I have 10 places to put the dogs, and I need them to be groomed, okay? So when I choose my first dog, how many options of dogs do I have? I have 10. When I choose my second dog, now how many options do I have? I've already groomed one. And so this is what happens. Okay, well, now I have 8. Well, now I have 7. Well, now I have 6. Well, now I have 5, and we're going down, right? So when it says, in how many different ways can 10 dogs be lined up to be groomed? It's 3,628,800 ways. It's a lot of ways to line up 10 people, by the way. How many ways then can you arrange 6 trophies on a shelf? Well, once you have arranged it, you can't he's already been used. So that's going to be 6 factorial. Now, I will say, I want you to know what factorial means. I am not going to require that you manually calculate it because in your calculators, there is a way to do factorial. All right, so get your little calculators out. And you're going to go to, mine says math. So in your calculator, you're going to go to math, then to probability, then to factorial. There's 14 and 2 of them are missing. But if I want to pull just a small group out of the total group, I'm going to do a permutation. But then I have a problem because I'm not counting all 12 of you, but I have multiple groups of 3 I could yank, right? And then on top of that, of those 3, order matters what order I put them in, okay? So if I'm looking at this, I'm going to say N is how many people I have. That's 12. I have 12 kids. R represents how many kids I'm pulling at a time. So 3 kids. So if I'm taking out 3 of you, that's going to be my R. That's going to be my R, okay? So basically I'm saying 11 things taken 3 at a time. Right? Or however many things I have in total, taken how many at a time. And I'm saying order matters. And this P represents that order matters. So the formula for this is the total number that I have, that factorial, divided by the number that I have minus how many I'm trying to pull at a time over that factorial. And that will give me the total number of arrangements I can do for 11 people taken 3 at a time. Okay, permutation. In this case, they did 10 and 4. I had 10 total. I wanted it 4 at a time. So I would say 10 factorial over 6 factorial. It would be 5,040. Now, again, in your calculators, you can do this, all right? Now, I will say you have to put in the first number first. So we're going to practice using the 10 and 4. You need to put the 10 in. Then you need to go to your math menu, to your probability, to your NPR, and then hit your enter. Then put in your 4, and then hit enter again.
For
You're going to put in your first number. If you do not have an NPR and a permutation or a combination button on your calculator, it's going to be inside one of your menus, okay? So you're going to put the first number, the total number of people or whatever in the group that you have. Go into, for this one, you're going to go into, no, go back. You're going to go into math, then your probability menu, then your NPR, and then you can hit enter. And then you're going to put in your 4. So let's look at this example here. Look at example 2. 7 yachts enter a race. First, second, and third place will be given to the 3 fastest yachts. How many arrangements of first, second, and third are possible with 7 yachts? All right. So you know automatically order matters because it's first, second, and third place. Okay. So we look at the total. So first of all, determine what is this? This is a permutation of 7 yachts taken 3 at a time.
I like this a lot.
And so, you know, the formula is going to look like this. If you put it into your calculator, you should get, there are 210 different arrangements of first, second, and third place for those 7 yachts. All right. A selection in which order does not matter is combination. That is the example that I gave you where I just said, hey, I need 3 of you to help with something. I don't care what order you're in, right? So when order does not matter, this is considered a combination. Here's the formula for combination. You'll notice it looks very much like the permutation, but your denominator has also the number of that you're grouping. So combinations are actually smaller. It makes sense. If I took all of 11 of y'all and did first, second, and third place, then that one group I could rearrange 3 different times, or actually more than that, and do first, second, and third multiple ways, okay? So permutation is going to yield a higher number of possibilities because order matters. Combination will not. Combination will be smaller. There are fewer ways to arrange you if I don't care about your order, okay? Because that group of 3, you're not going to use again. If I was using first, second, and third, I could use that group of 3 again and again because I could put them in different orders, okay? But if order doesn't matter, it's going to be a smaller number. So in your calculator, it will also calculate your combination, all right? I want you to conceptually understand. You don't necessarily have to memorize the formula, but you need to understand that the formula includes something else on the denominator, which is going to make it a smaller number, okay? And so when you're looking at these, you may get some examples like this where I just say, hey, evaluate it. Well, that's easy because I'm going to allow you to use your calculator, okay? So you're just going to do the combination. But more than likely, it's going to look like this guy here. All right, a reading list for a course in world literature has 20 books on it. And how many ways can you choose to read the 4 books? Order does not matter. If you have read the 4 books, it's not like you're going to read them again in a different order, okay? You're just reading 4 books. So you're going to get multiple examples, and I'm going to say, tell me, is this a permutation or a combination? And then calculate the total number of ways it can be arranged, okay? And so you have to look at them and say, order matters here, order does not matter here. And you have to tell me what it is and then calculate it. So in this case, you're going to say order doesn't matter. It doesn't matter what order I read the books in. It doesn't change the group itself. So this is going to be a combination. And so it's going to be a combination of 20 things altogether. And I am taking them 4 at a time. And so I'm going to calculate that. And it's going to look something like that. 4,845 ways to read 4 books out of the 20.
So like
okay. All right, 10 candidates are running for 3 seats in student government. You may vote for as many as 3 candidates. And how many ways can you vote for 3 or fewer candidates? 3 or fewer. So we're going to look at voting for 3, then voting for 2, then voting for 1, and then voting for none. Because 3 or fewer. Now, I will say, you just add these guys up. All right? They're running for 3 seats in student government. So does order matter or does it not? Just 3 seats in government. It doesn't. They did not give me titles of these seats. It's almost like a student council that it sounds like it's running, okay? So they are telling me then that I have 10 candidates to choose from, and I have 3 or fewer. So I'm going to start with 3. So if I have 3 candidates that I'm going to vote for and 10 to choose from, that's going to be a combination of 10 things taken 3 at a time. Or, and I'm going to add to it, I could only vote for 2. that would still be a combination of 10 things, but now I'm taking it 2 at a time. I could vote for 1. That would look like this. I could decide not to vote for anyway. By the way, when it's 0, you can only take 0 options one way. Okay, so this seems like it would be 0. It's actually 1. There's only one way you can vote for 0 people. It's by not voting. Okay, so this is going to be 1. All right, so when you put these in, you're going to get 120. You're going to get 45 for this guy. You're going to get 10 for that guy, which is always true there. And you're going to get 1 for him. So the total number of ways you could vote is 176. All right. So when you see the word 3 or more or 3 or fewer, you're going to do every option from there until you have no more options. Okay?
Will you have one like